Right, here's another electrical adventure. Lee brought me this when he visited last time, and we fixed various things, and I was going to film fixing his Husqvarna chainsaw, but it never seemed to happen. Yeah, you have problems when chainsaws, petrol chainsaws, are only used occasionally. Anyway, cracking on. We have this Afore solar grid inverter. I think it's a 2.7 kilowatt, and we put it on the test rig and there was absolutely no life whatsoever, and we were about to go, oh well, that's it. And I said, hang on, we'll just take the top off and see if there's a fuse, and I'll show you it later on. And lo and behold, there was a fuse, and we put another fuse in. I think this is a 20 amp, and it started on the test rig, and as soon as it got to the point where it was going to connect, the fuse blew. Right, so there's a dead short somewhere. Now, I've had several of these, not this particular one, but several inverters with dead shorts. And in the past, people have said, oh, it's one of the capacitors, it's gone dead short. Yeah, and I'm thinking, well, anyway, you know, there comes a point when there's only one way to find out. So we're going to dig into this one, and I have dug into it and made some experiments before I did this video, and let's see what happens. They are really quite nicely made, as you will see. And if you saw in the last video about the, what was it now, the Solis OV10 video, you'll have seen already the inside of one of these, and it's they haven't scrimped on the case at all. Right, let's crack on. Right, these are actually Allen heads as opposed to Torx. Right, let's have the top off, and it just lifts off, no ribbons. And this, I don't know whether you can see this, but look, that's about 5 mil thick solid aluminium. Amazing. So here's the inside. Okay, and I don't know whether you can see this. Just there is where the fuse was. Is that better? Yes, that is. So there's where the fuse was. Obviously I'm in experimental mode. I'm going to point out various connections and screws, and then I'm going to undo it all. So first of all, we've got, first of all we have plastic screws here. There are 4 plastic screws. You need a tin to put all this lot in. Okay, so don't be afraid of taking things apart. And if in doubt, photograph it first. In fact, just always photograph it, because you never know when doubt would creep into your mind. Which way does this go? Does this red wire go to this one or this one? Luckily in this lot, most of them are labelled. Right, so that lifts off. Okay. And then we've got this wire here that comes down to here. Yeah, and that was hot glued in place, but of course it's no longer. Then you need your best glasses on, because let's just have a look. Can we zoom down? See those? That little connector there and there, and you have to squeeze those tabs down, and there and there. Squeeze the tabs, and then you can lift this out. So let's just see, my hand's going to get in the way. It's just typical. When you get a camera in position, it just makes life so much more there we go. Can you see what I'm talking about? Let me just come round here. Squeeze those two tabs together and then lift that. And these bottom ones are more difficult. Right, that's that done. And then there's this ribbon. So unclick that, and that piece is out. To be put carefully to one side. Now we have this white connector here. Which is the NTC temperature sensor. So what we've got is there's a mounting screw there and one there. One there, one there, one there, and then the negative DC goes to there, which is PAVAN, sorry, PVAN, and then the positive goes to PVA. Okay, we've got a screw there, which is a, well, it's a bracket that holds down two of the semiconductors. Coming along, we have a spade connector to A1, so that black one goes to A1 there, yeah, and this is marked LA1, yeah. Okay, now that's a spade connector, and it's got one of those little locks, so you've got to squeeze it. Coming further up, you've got the red one goes to down there, okay. And coming back down here, I don't know whether you covered that one, there's a screw there. So I'm going to take all that lot apart. That probably took about 5 minutes to get that lot out, so it's not too bad. Let me just turn this over. There we go. Now then, I've already had those three capacitors out. Those ones there. And they are, what were they now? 500 volts at 470 microfarads. And they were all fine. They all clocked up at 435. That's fine. So now we have these semiconductors. Right, so let's just zoom down a bit. That one there is a diode. Yeah. And all the rest, I think, are insulated gate bipolar transistors, IGBT. Now this is where I'm getting to the point where a lot of people will know a lot more than I do, but with brief research, so as you can see, the FETs, or whatever they are, IGBTs, are on the Afore board are K30H603, and the ones that have come out of the Aurora are K50H603. And having looked at the specs, I think the only difference is the amount of current they'll handle. I think both of them take 4 volts to switch on, and that's about it, and they're both the same IGBT setup. So I'm going to just check some of the ones that came out of the Aurora and see how we get on. Hopefully that makes sense. So that's the gate, that's the collector, and that's the emitter. So on these, that's the negative, that's the positive, and that's the switch, effectively. So if you, a lot of videos show you put a multimeter with the set on diode or continuity, and you put the negative to that and the positive to that off the meter, and you should get nothing. And then you put the positive to the gate, which is the signal, it's the switch, yeah, and effectively it switches it on, and then you should get something between those two. Now these ones have come out of a board that I'll just add a little clip in now. So this board here is from one of those Aurora 6 kilowatt wind inverters, and we have got some FETs in here, and they are K50H603 as opposed to K30H603. So I'm thinking they will do. So I'm going to desolder maybe 3 of these and then test them. So these have been stored up in the loft since I last did those last videos, and they've got some very handy 1000 microfarad at 300 volt capacitors as well, but they'll just stay in stock. Right, I'm going to desolder these. I'm not going to show you me struggling with it, but I will be using the soldering iron and a solder sucker, and we'll get these out and then we'll go from there. So here's one of the tests. You put the negative on there, switch the meter on, and you put the positive on there, and it's nothing. And you put the positive there, and then you come back to that. So this is what I was saying about it needs 4 volts. So let's get the bench power supply out and see what happens. And of course, if you put these, if you put the positive there, negative there, that I believe is a diode reading. We've got one over here that I think is Duff. So let's see what the diode reading is on that. Oh, it's the same. Right, let's get the bench power supply out. Okay, so we have got, let's put this on volts, and we've got the bench power supply, and it's at 4.5, 4.6 volts. You can see that, can't you? Okay, so that should be enough to switch these IGBT on. So we put the negative to there, which is the emitter, and we put the positive to the gate. Okay, and we're on diode, so negative to there, and we got nothing on that one, but that's out of the duff pile. So let's try one out of the potentially alright pile. We had something then. Okay, did you see that flash up? And then it went flat, so it went off. So I think that's a dead one. So we put, there we go, and this one is, and it stays at 698, and it's just staying there. 7, 6, 5. Okay, so that is maybe, at least it works of a type. So the next one, and that is dead. Let's try it again. Yeah, that's dead. So here's the inverter board, and we've got the meter set on. You can just about see that on diode setting. Now I've got to remember that's the gate. Okay, so that's the negative because we're upside down. So I want to see what's happening here. These are switched off. That one is a dead short. That one isn't. Now it could have been that that's a dead short that switched that one on. So that's a dead short. Yeah. And that one is not. So there's where our dead short is. That's alright. So it's those two. Okay, so it's that one and that one. So when I flip them over, it's, well, let's try this one up here. Yeah. So it is that and that. And that's fine. Okay, and that's a diode. So there's nothing happening that way, and there's something happening that way. That's fine. So it's this one and this one that need theoretically replacing. How we're going to do that, it's going to take some fine thinking, because I want to, let me just put this on here. Because the solder joints are, where are they? Those three there. So we need to heat those up without damaging all this lot here, and then remove, then go the other side and heat that side up. We've got to heat it up and suck the solder off, then go the other side, heat it up, and then ease them out. But I want to make sure that I've got the right ones, so I'm just going to mark them, and then we'll crack on. Before we go any further, that is one of the ones that seems to be faulty. It's got a dead short on it, and that is a K30T60. And the other one that seems to be faulty is that one. And although we can't seem to read the number in the camera, it's the same one. So I'm just going to have to check what a K30T60 is. But look, can you see that crack there from the hole? I need a pointer, I can't find one. Just there. So that looks like it's got mighty hot. The other one doesn't look damaged, but a K30T60. Let's just see what they are. We've been working on this, and I had those IGBTs out of there, off the board, and one of the K30H603s was I think it was Duff, but the K30T60s, of which there were two, those are the ones that showed a dead short. Yeah, when they were out they still showed a dead short. So we put all this lot back together. I've just got to put the board, those little boards in there, but everything is screwed back together. All the wires are on. It took a fair old time to get those IGBTs out of the board carefully, and then of course, you know, test everything, and then the ones that are salvaged from the other board cleaned up and straightened and la la la. So you wonder whether it's worth it, but this is a spirit of adventure and really wild things. So coming round here, these are the can we read it? No, we can't. Doesn't matter. These are the K30T60s, and we've got this on diode. Yeah, dead short. So that was a good call, but you know, you've got to take them out to verify your investigation. So I'm going to put the rest of this back together, and then we'll put it on the test bench and hope that the blue smoke dragon doesn't escape. Right, get back to you in a minute. Right, we've got things on test. We've got the mains in, and we've got DC. Well, something's happening. And there's some clicking going on. It hasn't blown the fuse. I have no expectations of this, which is a brilliant way to go on. There's no blue smoke. There's no warning lights. Oh, something's happening. The variac's starting to hum. Ah! What was that? Okay, it wasn't a blown fuse. we're just going to have to wing this one. It's saying wait there. DC voltage should be high enough. Yeah, 180 volts on the PV, which is more than enough. Don't tell me it's got another fault. We got a got another fault. Never mind, I learnt a few things here. B, information transfer. Right, that's obviously a fault code of some form. Right, could be the relays. It's not blowing the fuse, which is, so the dead short has gone, but maybe there was another fault that caused the dead short. Or on these they've got 4 relays and you can hear them operating. They're down here, but they look particularly difficult to get to. But I think if I wanted to go any further, it would be again bored out and have the tops off those relays, because I think now we have a relay fault, because the relays start to sort of click and then drop out. I suppose we've moved on from the initial fault. Here we go, the variac's loading up and the relays have dropped out again. Right, I'll leave it to that. Any comments? Be lovely to hear from you, and I shall catch up with you soon. Cheers for now.